The last landform I will introduce you to is Galaxias. This is one of these landforms which doesn't exist on Earth. So the paper published on Galaxias is called Chaos Formation by Sublimation of Volatile Rich Substrate, Evidence from Galaxias. What is important is that we are, first of all, suggesting a new model for chaos formation. Secondly, we suggest that this chaos formation is stratigraphically controlled by sublimation of a volatile rich substrate that we suggest is the Vestidas Borealis formation, which is a big formation that is situated in the northern lowlands. And generally this work has implications for how we define chaos or how we should understand chaos in general and the formation models. It has implications for how we understand the stratigraphic relation between this formation called the Vestidas Borealis or VBF and lavas in the region, as well as suggesting that we should work on the nature of this unit and understand how this unit is degrading. So what is chaos? Basically, Struble and Masuski says that chaos is just a distinctive area of broken terrain. It looks something like this, or this is an older picture. You can have some chaos-like features here and some big outflow channels. Their morphological characteristics are usually angular blocks, flat. They are often flat top that you can see here. Here you can see some flat top blocks. And they usually have the same surface as the surrounding area. The topographic differences between the blocks here and the surroundings is in the order of hundreds to thousands of meters. So that in several places there's a kilometer or two drop here in between the surrounding surface and the blocks itself. And as I said earlier, they have been associated with big outflow channels, the ones you saw on the Google tour. So, landforms that have been named chaos, there's 26 of them on Mars. And basically 21 of them is situated here in the region of the big outflow channels, and 5 of them outside. One of them is up here. So this landform is pretty enigmatic, and various formation models have been suggested. Magma excavation, so drainage of a magma chamber, cloud rate dissociation, catastrophic groundwater release, thermal insulation by overlying sediment of pure ice, degradation of ground ice, and magma ground ice interactions. So just to show you again, so here we have the geomorphologic map, and this is the Galaxias region that I'm now going to talk about. So this is the overview of the Galaxias region here. What you see in the center and to the east of the Galaxias region is these polygonal blocks looking like a jigsaw puzzle. To the west, they have been modified by later fracturing of graben structures, so they have been modified and have not been used for this research. And generally, if you go further out into the northern lowlands, we see something like this. We call this the plains unit, and this is similar to what Tanaka et al. 2005 call Vestidas Borealis. And what we see here is some knobs that are poking up from below. We also see draping of this deposit on top of some of these blocks, suggesting that this deposit had been shrinking over time. So what we started out to try to investigate was to see if the material on top of Galaxias is the same as what we see at Elysium Plateau. So we were looking for dark surface layers, tracing them for Elysium Plateau, which is down here, and all the way into Galaxias, seeing that these layers look like they were fairly the same. We also looked at these kind of rough texture that is enhanced over here, and see that we can see them all the way from Elysium Plateau into the Galaxias region. And we also were mapping out flow fronts. You can see a small flow front here on Elysium Plateau, and we could find similar stuff out here in Galaxias. And so we concluded that the material on Elysium Plateau, which is mainly lavas, would be the same in the Galaxias region. Moreover, we looked at the trough development in the chaos region. And what we saw was that we have various stages of troughs. We have some small depressions within the block, within a block looking like this. We have some fracturing on the sides of the block. We have troughs that seems to migrate along a linear depression here. Also here you have a block, you have troughs right here. The sun is coming from here, so it should be a trough for you. And we see some linear depressions here, which seems to control the growth of these troughs. And this is what it looks like in the end. Generally, this study shows us that we have gradual trough formation. So it's not a catastrophic process. It's a gradual process in this case. Then we look at the topography. And what you see here is different topographic profiles. They're starting here from south on the Elysium Plateau and going towards the north. So this is Elysium Plateau and this is the north. And this is just for highlighting two of the most interesting topographic profiles. What you see is that the blocks is 100 to 200 meters tall. And generally, they have the same elevation more or less as the Elysium Plateau. So we don't see this big 1 to 2 kilometer drop between the surrounding surface and the chaos itself. Moreover, we see that the chaos generally develop along a belt on Elysium rise in minus 3.6 kilometers to minus 3.7 kilometers high. And then we see that some of these blocks is actually elevated compared to the surroundings. Another study of the topography was this one, where we found these blocks, and especially this one here, looked like it was a block that has been in one piece, but broke in the middle. And when we looked at the topography, we got something like this, showing us that this part of the block is tilting this way, and this part of the block is tilted this way. So, if this truly was one block before, it must have been at the same level, more or less, to be one block. And this suggests that we have a fair amount of subsidence. So this block has been stalling on the subsurface somehow, and as the deposit it was lying on top was shrinking, we would have this kind of breakage of the block. So basically, what we see is that Galaxias chaos is pretty different from other chaos regions as the one from the big outflow channels. The topography is very different. There's no huge outflow channels, and this gradual trough formation governed by local stress and not regional stress. So again, if we look at the formation models, this fact that there's no huge outflow channels and it's governed by regional stress suggests that we are not talking about these four models up here. And probably we are rather talking about something about degradation of ground ice. And just to remind you here, we are located right here. Here we have the Elysium lavas, and here we have the plains material, which we saw on the second and third slides of this study, experience shrinkage. Have become smaller. And this is the same as Kanaka et al. Mapped in 2005 as Fastidious Borealis formation. So what we suggest is that this chaos landform formed due to sandwiching this ice-rich deposit, Fastidious Borealis formation that we suggested is, between Elysium lavas. And as this deposit became more unstable, it began to shrink. And this gradual volatile loss and shrinkage started a substrate movement. So this is shown in the red arrows here. You have the orange arrows is showing sublimation of the ground ice. And when you're simply undermining the lava cap here, you're creating local extension in the lava cap. And when you have undermined it so much that the lava cap cannot sustain itself, you get troughs. And when you got a trough, then you will enhance the sublimation and you will get depression and trough formation and trough growth. So basically this model explains why some of the blocks are elevated compared to the surroundings, why we have similar elevation of chaos formation, why we see that it's a gradual process and not a catastrophic process. And it also explains the cell-like nature of chaos. So we suggest that the story looks something like this. We have Elysium Plateau here, lately barren lavas are emplaced. Then, as we go on to the early Amazonian age, we have emplacement of the Fastidious Borealis formation here in the base, and then furthermore some new lavas on top of it. Then Fastidious Borealis starts to lose its volatiles and shrink. and you get the trough formation here along this band of Elysium rise. And then in the end, to the west of the Chaos region, we have further deformation of the region due to volcanic activity. So basically this model suggests a stratigraphic control of chaos formation. And so we started to look outside our study area to see if there was other places where we have a Steta borealis formation and lavas bounding each other. And what we saw is, this is Elysium Plateau, up here is Galaxias chaos, and the colored lines here are contour lines. And what we saw when we moved further on to the west was these fractured rises looking like this and this, which is fairly similar to what we see in Galaxias chaos. So this fits pretty much that we have kind of stratigraphic control on our formation. And then you can ask, why don't we see something here? But here we have a lot of later outflow channels that would have covered up everything right here. So, Galaxias chaos deviates significantly from other clouded regions because of the lack of outflow channels, small topographic relief, and gradual trough formation. And we propose a sandwich model, which is basically just explained here one more time. So this study implies that we should be more careful about using the term of chaos, or at least just be aware that chaos in general is formed in various ways and not just in one way. It constrains also some of the properties of VBF, and it would be helpful if people are looking more into the Vestiges borealis formation, how it morphologically look like, and suggest some emplacement and degradation mechanisms of this deposit to control how much H2O there might have been deposited in this unit and how much that have sublimated. So basically this slide is just to sum up what we see here, what I've mapped out in the entire region. So the geomorphological map of the Galaxias region is produced in 1 to 400,000 scale, has been mapped on 1 to 100,000 scale, and is containing 7 different groups of landform systems, and in total 23 different kinds of landforms. And you can see their aerial percentage here. And most of this activity is within the early Amazonian age. So basically, around 45% of all the landforms we see in the area is generated by volcanism. And moreover, a total of around 50% of the deposits, or up to 50% of the deposits, might have had some kind of ice and have experienced some kind of later sublimation and degradation. Yes, I think that was it. Thank you for your attention.